In the second part, you'll have to create history aggregation count table. This is the first table of part 2, wherein you'll have to read records from transaction underscore hist table, do some Spark batch processing, and load it in transaction underscore hist underscore aggregation count 5 years. So you'll have to create a transaction history aggregation table which would contain only counts. Now, if you see the columns, we have customer ID, customer country, then there are various count or counters that will have to load. Cross-country transaction count for the last 1 year, cross-country transaction count for the last 2 years, to cross-country transaction count for the last 5 years. Similarly, savings transaction count for the last 1 year to savings transaction count for the last 5 years. Checking transaction count for the last 1 year to checking transaction count for the last 5 years, and so on. Not only that, you'll have device mismatch count also. And these are all counts, and description of the columns are mentioned in later slides, which is this one. This is the column description of all the tables. Just wanted to tell you about the transaction history aggregate count. In the details, it tells you how or what you have to load in these columns. It can be from 1 year to 5 year. But the table name is transaction history aggregate count 5 years, and the column name is cross country transaction count 1 year, 2 year, 3 year, 4 year, 5 year, and etc. Now this column or these columns should contain the count of transactions where the source country and the destination country were different, which is cross country transaction. And you have to do it for the last 1 year, 2 year, 3 year, 4 year, and 5 year. Now, what should be the last year, what should be the last 2 year, etc. You have to consider 2027 as the current year. So last year would be 2026, second last year would be 2025, then 2024, and so on. Now the count should be aggregation of all the years. It should be a cumulative aggregation, meaning for the last year, it should contain all the counts for only 2026. For the last 2 years, it should contain count from 2026 and 2025. For the last 3 years, it should contain counts from 2026, 2025, and 2024, and so on. Similarly, savings transaction count would contain count of transactions from saving account in the last 1 to 5 years. Checking transaction would contain count of transactions from checking account in the last 1 to 5 years, and so on. Similarly, you have credit card, debit card transaction also. There is one column called device mismatch count, and here you should contain the number of times where the device ID used in the transaction is different than the customer device in the last 1, 2, 3, 4, 5 years, meaning that the customer device and the transaction device ID do not match. So this is the first table, which is transaction history aggregation count 5 years table. Then you'll have to create a transaction geography table. This table has to be created from all the 3 tables, which is transaction table, customer table, and transaction history table. Now the transaction table would be in Aurora MySQL, so would be the customer table, but transaction history table would be in Redshift. So I'll have to use Spark batch processing data frame API to read from Aurora and then load it to transaction geography detail table, which would be in Redshift. And the transaction geography detail table would contain customer ID, transaction distance from base. Now, this is the place where you have to use the Haversine formula or the Haversine module that you have created in the previous project. Now, what do I mean by transaction distance from base? You'd see in the customer table, we have customer location latitude and customer location longitude. Similarly, in the transaction table, we have transaction location latitude and transaction location longitude. So we'll have to find the distance between the customer location and the transaction location using the lat long that I have provided. And that would be the transaction distance from base, meaning how far from the base location the customer has performed the transaction. Then you have transaction device ID and the device mismatch, which would be a flag whether there is any mismatch in the device. The customer country, transaction currency, which has to be generated by you, which is there in transaction history table. And in the previous ETL, you had to create the currency column, you see, by looking at the source country. The currency should be as per to the source country. Then there is browser used, which can be retrieved from the transaction history table. So this is the third table that we are preparing or creating on Redshift. First was the transaction history, then it was transaction history aggregation count 5 years, and the third table is the transaction geography detail. We'll have to create one more table, which is a very important table because this is going to be used in the fraud detection. And this table would be risk score table, and the name of the table would be calculate risk score. The input tables would be transaction history aggregate count 5 years, transaction geography detail, transaction history, account, and customer table. So we'll have to take input from all the 5 tables. 3 of them are in Redshift and 2 of them are in Aurora MySQL. These tables would be used as input and then loaded using Spark, and then you'll have to use Spark SQL to load the data in the calculate a risk score table or calci risk score table. You cannot use data frame API. You have to use Spark SQL for this. Now again, you have to understand the purpose of the hands-on. I want to make sure that you practice using data frame API, Spark SQL, and then Spark streaming also. At the same time, you'll be using multiple sources like file source, database source, data warehouse, source, and target. All right. Now, calculate risk score would contain 4 columns: customer ID, risk rule number, risk rule description, and risk score. Now, where do you get this risk rule number and risk rule description from? You'll get the rules from here. For example, rule number 1 says that cross-country transaction from credit card with 5-year count more than 10 should have a score of 7. If the count is more than 15, then the score should be 8. And if the count is more than 20, the score should be 9. Similarly, rule number 2 says cross-country wire transfer transaction where the transferred amount is more than 25% of the account balance, then the risk score should be 5. If it is more than 35% of the account balance, then the risk score should be 6. 45% should have a score of 7 and 50% should have a score of 8 or 9. Anyway, 25% is 5, 35% is 6, and so on. Similarly, there are 10 rules. Rule number 1 to 10, and each customer should have these scores created in their risk score table. So ideally, each customer should have a minimum of 10 rows and a maximum of a little bit more rows, because here you'll have to insert 3 rows for 3 different risk scores. One is for count 10, one is for count 15, and one is for count 20. So rule number 1 would actually have a right inflation of 3 rows per rule. In this case, it would be 5 rows per rule, and so on. Again, not mandatory. This is the ideal situation. It would depend on the data that you have in the customer transaction history and other tables. So these are the 10 rules, and these rules would be used in real time to find out whether a transaction is fraudulent or not. If it is fraudulent, then would be sending a notification to the customer. So this is the 4th table that we'll have to create in Redshift, which is calculate risk score. Then there is one more table, which is transaction history aggregate last year, which is transaction last year aggregate table. Again, last year should be 2026. And you can create this table from transaction history table, but you have to consider data, or you have to consider transactions that belong to the year 2026 only. You cannot use data from year 2025, 2024, 2023, etc. So you'll have to consider the data which belongs to year 2026 in transaction underscore hist table. And then you'll have to use PySpark, and it's up to you whether you want to use data frame API or Spark SQL to load this table. And these are the column names. We have customer ID, last year, current year, month number, YTD, average monthly transaction amount, which means average transaction amount per month till date from beginning of the year. So I'll have to calculate the transaction amount for every month. So I'll have to extract the month, do an average, and then insert the record. We have average weekly and yearly also, and I have a column only month number. You can mention or you can add a column week number also for a particular month, because there's YTD, max weekly transaction count. So in a particular month, what was the maximum transaction amount per week till date from beginning of year? Similarly, minimum transaction amount per week till date from beginning of year. Average transaction amount per week till date from beginning of year. So I think you should add one more column, which is week number. And I have already put the column which is WK underscore number. This is the week number and it can be anywhere from 01 to 05. I don't think there would be any month with 6 weeks, but anyway, whatever is the week number, you'll have to get the week number and put it there. Similarly, you have average yearly transaction amount, max yearly transaction amount, minimum yearly transaction amount, total transaction amount. These are the description of the columns. And if you do not understand what these description means or what are these columns, you can ask a question in the comment, drop me an email, or we can discuss it in our cohort also. There is one more set of columns which is YTD, average monthly savings transaction amount, which means that average transaction amount per month using savings account, then checking account, credit card, debit card, etc. This should be POS actually, it should not be debit card. So it should be using POS till date from beginning of year. So there are a lot of columns here and you have to do a lot of transformations, and I don't think the transformations would be easy. I have not done the coding. Obviously you can discuss it during our cohort or in the comments also. And there's one more column that I wanted to have a description on, which is device mismatch. It should be either yes or no. It would be a flag to mention whether there's any device mismatch or not. So there are only a few source tables, but so many target tables. So the ETL would be a little different. And that is the part 2, which is ETL 2. Now here what you have to do, we have account table in Aurora MySQL, customer table also in Aurora MySQL, and transaction history table is there in Redshift. So you'll have to read from these 3 tables using PySpark data frame and then load it to 2 tables, which are transaction geography detail table and transaction history account count 5 years table. So these are the 2 tables which have to be loaded from Aurora MySQL and Redshift, because there's a mix and match in both the places and you have to use PySpark data frame to load to these tables, and all these tables would be in Redshift. Then you have transaction history aggregate last year table, which would be loaded from transaction history table. So transaction history table is also in Redshift. You'll have to read from Redshift, use PySpark, do the transformation and load it to transaction history aggregate last year table. And you can use either Spark SQL or data frame, whichever you like. But the calculate risk score table, which has to be loaded using transaction geography table, transaction history aggregate count table, the account table, customer table, etc. That loading has to be done using Spark SQL, and this table would also be in Redshift. So you'll be able to practice PySpark data frame and Spark SQL to do the transformation and aggregation and then load it to a target table. So for these 2 tables, the input would be transaction history, customer and account. So you see the arrows here, and then these 2 tables would be created. For this table, which is transaction history aggregate last year, there's only one input, which is transaction history. For calculate risk score table, there are 4 input tables which would be needed. This is the first one, this is the second one, account is the third one, and customer is the fourth one. I think there would be an input needed from transaction history table also. So if that is the case, you'll have to use transaction history table also. So this is the first part of data preparation for financial fraud detection. Once the data are prepared, then we'll be receiving data from Kafka and we'll have to do real-time analytics and check whether a particular transaction is fraudulent or not. If it is a fraudulent transaction, we'll have to send notification using Kafka also. So please go ahead and complete the first part first, then we'll move to the second part.